Hi everyone, welcome back to Lulumath. This video is on finding equations of quadratic relations in standard form, and standard form is y equals ax squared plus bx plus c. Before we can actually find these equations, we need to know what standard form is of a quadratic relation. We need to know how to find the equation of a quadratic using vertex form. And just a reminder, vertex form is y equals a multiplied by the quantity x minus h squared plus k. And we also need to know how to find equations of a quadratic relation in factored form. And just a reminder, factored form is y equals a times x minus r multiplied by x minus s. Now, really quickly, just a reminder that your vertex will be hk and that your factored form will tell you the roots. All of that information and more is available at lulumath.com as well as the Lulumath YouTube channel. Make sure to check those out if you need a little bit of a refresher. So in the question that we see here, we're asked to find the equation of a quadratic relation in standard form. And just a reminder, standard form is y equals ax squared plus bx plus c. The problem with standard form is that we can't plug really a lot of information into standard form. So we're going to have to resort to either vertex form or factored form. But when do we use what? Well, vertex form will be used when we're given a vertex, and factored form will be used when we're given roots. And it should make sense to you that you should use vertex form when given a vertex, but the factored form to be used when given roots is not as obvious. So in this example that we're given here, we're given 2 points. We're given a vertex and we're given an additional point, and we need that additional point to determine the a value regardless of whether we use vertex form or factored form. Since we're given the vertex, we are going to use vertex form. And I'm going to go through how to solve for a quickly, because if you need extra information on that, go ahead and take a look at that video. I want to focus more on how to go from vertex form to standard form once we actually solve for a here. So we know h is 5 and we know that k is -6. So I will plug all that information into my equation. Now, at this point in time, I don't have enough information about a, so I need to plug in another point to determine what a is. So I will use this point 3, 2. And I know that x is the 3 and y is the 2. So I will plug in 2 right here and 3 here, and then I will copy the rest of the equation down exactly how I see it. I'll go through and solve for a. So here I know 3 minus 5 is -2. And then when I square this -2, I end up getting +4. So I'm going to rewrite this as 4 times a. I will add the 6 to both sides. And when I add the 6 to the left side, I get 8. And then -6 plus 6 is nothing, so it cancels out. So that means that a is equal to 2. And that can go in right here. So y will be equal to 2 times x minus 5 squared minus 6. So this is my answer in vertex form, but we need to know what the answer is in standard form. So I need to expand and simplify in order to determine my final equation. So we will add this on to our background knowledge. So you either need to know how to do FOIL or do the box method. So if I were to expand this x minus 5 quantity squared, remember it's not x squared plus 25, it's x minus 5 multiplied by x minus 5. And if you need some help with this, please make sure you check those videos out. I'm not going to spend the time on how to actually do this expansion. I'm just going to say that this is going to be x squared minus 10x and then plus 25. I suggest you do this work on the side if it doesn't come immediately to you, and that's totally fine. This will come with practice. And if you have any questions, please reach out or go back and watch the video on FOIL or the box method. So since our equation was y equals 2 times x minus 5 quantity squared minus 6, and since we expanded this here, we can rewrite this as y equals 2 times the quantity x squared minus 10x plus 25 will go in here instead of x minus 5 squared, and then minus 6. Now all I have to do is distribute this 2 through. So I end up getting 2x squared minus 20x plus 50, because 2 times x squared is 2x squared, 2 times negative 10x is negative 20x, and 2 times 25 is 50. I will copy down this minus 6. The 50 minus 6 go together and they give us positive 44. So my final equation is y equals 2x squared minus 20x plus 44. And I just want to show you here how our first graph that we have up here is y equals 2 times x minus 5 squared minus 6. This is what we got in vertex form. And then in standard form, we got y equals 2x squared minus 20x plus 44. And when I turn that on, you can see that it's exactly on top of the red graph, meaning that they are identical. They are the exact same graph. They're equivalent to each other. So that's how you put this in standard form. In our next example, we're asked to find the equation of the quadratic relation below in standard form again. So just a reminder, we use vertex form if we're given the vertex, and we use factored form if we're given the roots. Now the vertex is here, and it's not really clear exactly how much it is, so we're not going to use vertex form. We are, however, given the roots, so we will use factored form. And just a reminder, factored form is y equals a times x minus r times x minus s. Well, here we know that r is equal to negative 8 because negative 8 is one of our roots, and we know that s is equal to 3 because 3 is our other root. And it doesn't matter which one you say is r and which one you say is s. They are interchangeable. So here, when I start to identify how to do this, I don't know what a is, but I do know that r is negative 8, and because this is minus, we have minus negative 8, which turns into a plus 8, which I will write as positive in the next line. And then here the s is 3, so this will be x minus, and then we'll have a 3 here. Again, this minus a negative turns into a positive, so I will rewrite this as y equals a times x plus 8 times x minus 3. Okay, now I need to identify what a is, so I will use this coordinate that is given to me, this 0, 6. And again, I'm not going to go over how to actually solve for a. I'm just going to go through the process. Make sure you watch the video on finding equations in factored form if you need a refresher. So since a is 0 and y is 6, I will plug 6 in for y, and I will plug in 0 for x. Now I'm going to evaluate and solve. So here I know 0 plus 8 is 8, and I know 0 minus 3 is negative 3, and I will just copy down the a and the 6. Well, 8 times negative 3 is negative 24, and I will switch the order between the negative 24 and the a, because multiplication is commutative. And then I will solve for a by dividing everything by negative 24. So now we can say that negative 6 over 24 is equal to a, but negative 6 over 24, both values are divisible by 6, so when I reduce it, I get negative 1/4. So here I can say a equals negative 1/4. And I can plug that negative 1/4 in here for this a value here. So I can say y equals negative 1/4 multiplied by x plus 8 multiplied by x minus 3. But again, because we're asked to put this into standard form, I'm going to expand and simplify. So I will expand this x plus 8 times x minus 3. And I suggest you do the expansion on the side, do either the foiling or the box method. If you need a little bit of help, go back and check out the video or reach out and we'd be more than happy to help you out. So when I expand it, I would get x squared plus 5x minus 24, but this whole thing is being multiplied through by negative 1/4. So I will distribute that negative 1/4 through to each one of these values, and that will give me my final answer. So negative 1/4 multiplied by x squared is negative 1/4 x squared. Negative 1/4 multiplied by 5 over 1, negative 1 times 5 is negative 5, and then 4 times 1 is 4, so it's 5/4 x. And then negative 1/4 multiplied by negative 6, well, a negative multiplied by a negative is a positive, and 1/4 of 24, or 24 divided by 4 is simply 6. And this is my final answer. So just as a quick summary, we want to use the vertex form if we are given the vertex and another point. And we want to use factored form if given the roots and another point. And then all we have to do after that is just simply expand and simplify to write the equation in standard form. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be useful, don't forget to subscribe and share with others. Thanks, and we'll catch you next time. Bye.